Okay, hi guys, so we'll be continuing on seeing shape of orbitals, and now we'll be seeing dumbbell shape of p orbital. Okay, so let's draw the subshell, p subshell. So it would be something like px, py, and pz minus 1, 0, and plus 1. This is p subshell. Okay, so these are degenerate orbitals. As they have same energy level. Okay, so the shape of the px would be like this, like a dumbbell. Okay, and y and z plane are here. This is z, y, and x plane. Okay, so this is px, and it can have one nodal plane, which is yz plane. Okay, one nodal plane, which is yz plane, because the electron density across the yz plane would be 0. Okay, and it implies that it would be ungyrate, as for even number of nodal planes we have gyrate and it's called gyrate, and for odd number it's called ungyrate. So this is called ungyrate. Okay, now let's see the case of py. So in case of py, we would have dumbbell shape across y-axis. Okay, so this is again one nodal plane. So this is py, and what is the nodal plane? Nodal plane is nothing the plane, but the plane on which the electron density for the orbital is 0. Okay, so this is can be written as phi ungyrate. Again, this is the one nodal plane, which is xz plane, and again this is ungyrate, because it has odd number of nodal planes. Let's see the case of pz. So in pz we would have, similar to px and py, electron density across z axis. Okay, again this would have one nodal plane, and that would be xz plane, xy plane, and again it would be ungyrate, because it has odd number of nodal planes. Okay, so let's look at the shape of combined s and p orbital. So how would it look like? So our s orbital would look like, so this is the nucleus. Okay, s orbital would be something like this, and p orbital would look like this. Okay, this would be p orbital. Electron density across, this is the y-axis, positive and negative y-axis, positive and negative z-axis, and positive and negative x-axis. This is s orbital, and these rest are p orbital. Dot shows high electron density of electrons here. Okay, so this shows high electron density. Okay, and we would have both positive and negative sign of phi or wave function. So here both can occur simultaneously. Okay, so you can just have a note here that opposite lobes of p orbital have opposite sign of phi. It is actually but obvious, but just for the sake of documentation. So opposite lobes of p orbital have opposite signs of phi. Okay, now let us start off with the double shape of d orbital. Okay, so first let's draw the d subshell. Which is -2, -1, 0, 1 and 2. Okay, so this is nothing but dxy. Let me write it with a different pen. This is dyz, this is dxz, this is dx square minus y square, and this is dz square. So this is nothing but d subshell. Okay, and out of these three, dxy, yz and xz, would be called non-axial set. Okay, this would be called non-axial set, and this would be called axial set. These are also termed as T2G and EG. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing our other continuing more on double shape of d orbital. Till then, good luck and goodbye.